Alright everyone, so this is my first video, so bear with me. And this video is going to serve as a review of material in the first portion of Chapter 6, which we covered in about the week and a half before spring break. And so the topic that this is mainly going to address is regarding a single confidence interval for a population mean mu. Now, so the formula that we use to construct this confidence interval is first given by the point estimate, the sample mean, which we usually denote y bar. Now that's a point estimate, and then we add and subtract the margin of error. So that margin of error, recall, is composed of first the t critical value, and that's a family of curves, right? So you've got to distinguish which one you're speaking about with degrees of freedom. And since it's a critical value, it needs to be distinguished by the tail regions or the center region. In general, this notation refers to the tail region, the tail area, which is alpha, but that alpha is shared, i.e. chopped in half for the two tails. Now that is the t critical value that needs to be multiplied by the standard error. This is the estimate for the standard error given by s over square root of n. So this is the formula that we use for the confidence interval. So I can call this the confidence interval for mu. And I guess I could be a little bit more descriptive. This is a particular percent confidence interval, so I should write, remember alpha is usually a small percentage, so 1 minus alpha times 100% confidence interval for mu. So our t critical value, t critical, remember that's just a number from the t table. And we'll see how to find that value in R quite quickly. Over here, that is the standard error, s over square root of n, standard deviation over the square root of sample size, standard error. And over here, we've got the point estimate. Point estimate. So this is the general form of a confidence interval. Now it's quite specific in this case to a confidence interval for mu, but for the sake of kind of investment for the future, we're going to use confidence intervals in different contexts. So I'm going to rewrite this. Now it's going to be a little repetitive, but in general, the way a confidence interval is constructed in general, it starts out with some sort of point estimate, a single point estimate, add and subtract for our purposes, it's mostly some sort of t critical, of critical value from the t distribution, multiplied by standard error. So that's going to be used in different contexts in the very near future. In the next video, we will show an example using R and some of the requirements in order for a confidence interval to be valid.